Hi, this is Dr. Pat. We're looking at using matrices to solve systems of equations, and we'll just start with a nice little two equations with two variables kind of thing. Before we actually get into matrices, I just kind of want to talk about the steps that we use to solve a system of equations using the elimination method. That's the key. The substitution method or other methods that we use for solving system of equations doesn't quite fit with matrices as well. So that's why let's go with the elimination method, and then after we're done, maybe we can really demonstrate the connections. All right, so let's look at this nice little two equation. It's got two variables. Let's solve this and just kind of do some steps. I'm not going to do all the steps just for time wise, just to introduce the idea, and then we'll come back to this a little bit later. All right, so now what are the steps here to solve this? If I'm eliminating the x, what I'd want to do first is to make sure that my x's have the same number but opposite sign. So I want to create this negative 2x there on that second equation. And to create a negative 2x here, I want to multiply the whole second equation by 2. Not the first equation, I'm going to leave that alone. So I'm going to rewrite it. I'm going to carry this first equation, I'm carrying it along, okay, so I'm not forgetting about it, but I'm doing my work on that second equation, that second line here. And so by multiplying that equation by 2, every coefficient gets multiplied by 2, and so that's why you see the negative 2x and the 4y and the negative 8. Okay, so now that we've got our coefficients here for the x's being basically the same digit but opposite sign, we're going to our next step. And our next step is to add the two equations together. And so when we combine these two equations together, I'm going to get the second row right here. I'm going to get a nice 0x there, and then the 3y because of the negative 1 and the 4, and then the 3 and the negative 8 will give me negative 5. And once again, I'm just bringing this first equation. I know it's kind of dorky, or just like saying, dude, why are you bringing that? Kind of like carrying this extra bad baggage, like relationships. It's like, dude, you don't want baggage coming along. But actually, matrices, we're going to find out that we do like to carry this line with us. And so I'm just kind of giving a visual cue here that with the system of equations, it's perfectly legal for me to basically rewrite this system just like this. I can still have that first equation and the second equation. It still works. The same xy values are going to work for both of these equations. And then the next step would be, I'm liking this 3 here, or I'm not liking the 3. I want to get rid of this 3, so I'll divide this whole second equation by 3. And that's what I'm going to do. I'm going to leave the first equation alone, but I'm working the second equation. And of course, 0 divided by 3, that's 0 still. 3 divided by 3 is going to give me a 1. And then that negative 5 divided by 3 gives me a nice little fraction, 5 over 3. And negative y's. And so basically what I have in this equation is that I've got this statement, y equals negative 5/3. So you can see in the second equation, I have my y value. And of course, then I can take my y value, bring it up to this equation, and then solve for x. So it kind of makes sense for me to bring this second equation along with me because I'm going to eventually going to substitute it back in or need the second equation in order to find the x value. Okay, so that's what we've got. So we just did the elimination method to get x, to eliminate x to find our y value. And I'm just not doing that second stage just for time wise. But just these 3 steps I just wanted to show you that we can multiply an equation, we can combine the equations, and then I can actually take one of the equations and divide by 3 and get the nice coefficient of 1. See, I want to bring this attention to you that I got a 0x here and a 1 here with the y. And so that's what I really like this for my second row. All right, and we'll see that later on in matrices. So I'm just bringing that to attention to you right now. Okay, so legal for me to bring this first equation along and manipulate the second equation. That's okay. All right, so now let's look as matrices. Now, letters, we don't need no stinking letters. Basically, what we're going to do is all the x's and these y's and these numbers right here and equal signs and things like that, we really don't need to bring them along as long as we keep our columns pretty set. So as long as I know this column here is just x's, then we can understand what the 2 and the negative 1 stands for. Once again, the second column right here is all about y's, and this third column over there is about that constant on that other side of the equal sign. So basically, first two columns are about x's and y's, and then the third column is about the constant over on the other side. So let's just rewrite that. And so I'm just going to take all the numbers from these first equations and I'm going to write them in a row there. I'm going to take all the coefficients and numbers from this second equation and once again write them in a row. And what I've got here is my first column of numbers represents things with x's, the coefficients of x. The second column here represents the coefficients of y's. And then this third column right here is the constant numbers, the numbers on the other side of the equal signs. Okay, and so what we call this puppy, we call this an augmented matrix. It's because we've got this extra column right here of the stuff that's on the other side of the equal sign. That's why we're calling it an augmented matrix. It's not a coefficient matrix because of the 3, -4. If we just did these first two columns right here that represent the x's and the y's, that would be called a coefficient matrix because it has a matrix. It's a listing of numbers that has only to do with coefficients. But this one, because of the 3 and the -4, it's called an augmented matrix. Okay, so now what I want to do is just kind of manipulate matrices exactly the same steps as we did with the equations that we had. Okay, so now you may remember our first step when we were using the equations was we multiplied the second equation by 2. So that second row, remember the second row of numbers, -1, 2, and -4, was really from the equation -1x plus 2y equals -4. So this here in my mind, in my demented mind that I am, this represents an equation for me. And so we're going to do exactly what we did in that when we had equations. We're just going to multiply that second row, leaving the first row alone. We're going to multiply that second row by 2. And then you may recall, I'm just bringing this up to your attention. This is the equations we're playing with. And so the coefficients here match exactly the coefficients that we have in that second equation. And then remember we left the first equation alone, and that's still matching. And then our next step that we had was that we added the equations together, and I apologize. So what we were really playing with was not this matrix on top, is this one. When we add these two matrices together, we're going to get zeros here. We're going to get 3 and then -5. And so when we do add those two, what we have there is that second row, a rewriting of that second row. So it's like the second row there is just a listing of the new equation that we produce. And again, I'm leaving that first row alone. I'm manipulating the second one. Okay, and again, if we bring back our memory, what did our equations look like? It looked like exactly like this. So I apologize for this matrix up here. It's the wrong matrix. So yeah, got to go back that way. And so this is our equations here. It's matching still. So we're still going good. Okay, so now I've got my correct matrix here. And so what was the third step we did is we divided the second equation by 3. And we can do that once again. We can take this second row, which represents our second equation, and we can divide every number in there by 3. Because remember, an equation, you got to do both sides of the equation. And so as long as everybody gets divided by 3, we're good to go. First row, leaving it alone because we did not multiply the first equation by 3, only the second one. And so when we do that, we get this nice matrix here. And you may recall from the equations that we had, there was the 0x, there was the 1y, and then we had equals to -5/3. So what you're seeing here, hopefully, is the same exact steps that we did with the equations. We can demonstrate those same steps using matrices, which is basically a nice condensed form of writing a system of equations without using the x's, the y's, and the equal signs. So hopefully this is kind of like getting started for matrices. We'll do some more things, but the key thing I want to bring your attention to is this translation between equations and matrices, and that's what we're going to work on in our next video. So this is just a brief start of how to work it. We're not done yet because we technically only have the y value. We still have to solve for the x value, and there are things that we can do from this point on. Thanks and have a good day.